The brain, a very sophisticated organ. It controls thought, memory, speech, movement, and vision. Imagine if something went wrong. At least 1% of the world is diagnosed with hydrocephalus. Hydrocephalus is a condition in which there is too much accumulation of cerebrospinal fluid in the cavities called ventricles. The lightly shaded blue objects in the picture are called ventricles. If there is too much CSF in the ventricles, they can enlarge, causing too much pressure on the brain, seizures, headaches, loss of vision, and an increase in head size in infants. There is only one answer, and that is the VP Shunt. Hi, this presentation is going to educate you on the life-saving ventriculoperitoneal shunt. The VP shunt can be derived using the simple context clues. Ventriculo means the ventricles of the brain. Peritoneal means the abdominal cavity. And shunt means an alternate path. So we can conclude that ventriculoperitoneal shunt means an alternate path from the ventricles to the peritoneal cavity. But why would we need an alternate path? It's because of hydrocephalus. Let's start with the first part of the VP shunt, the ventricles. There are 4 ventricles located in the brain. There are the lateral ventricles. As you can see here, this is the left lateral ventricle. Then the right lateral ventricle. These are the lateral ventricles. Then comes the third ventricle. And then the fourth ventricle. And that little tube is called the aqueduct of Sylvius. Let's talk about the normal flow of CSF. The CSF flows from the lateral ventricles into the third ventricle and into the fourth ventricle. It leaves the fourth ventricle and into the subarachnoid space. The subarachnoid space is between the brain and skull, so the CSF flows into the subarachnoid space and gets absorbed by the granulations of Pacchioni. The subarachnoid space is around the brain and spinal cord, so when the CSF flows, it helps the brain and spinal cord to float. So what happens if a ventricle is blocked? Well, bad things can happen. If one ventricle is blocked, it can enlarge. As explained, the CSF is accumulating in the enlarged ventricle, thus increasing the pressure in the brain. So, a diversion is needed. This is how a shunt is placed. A catheter is placed in one of the 4 ventricles, and the excess CSF drains to a valve. This is a Spitz-Holter valve. The upper end of the catheter is inserted in the ventricles, and the lower end is inserted into the peritoneal cavity. The valve is designed to open only when the pressure of the CSF exceeds the pressure of the valve. This is the Spitz-Holter valve. Now, both catheters are attached to the valve and the CSF drains into the peritoneal cavity. To explain it further, here is a model of the ventricles on the VP shunt, made out of clay and straws. This ventricle is enlarged with high pressure. One catheter of the shunt is inserted into this ventricle. As you can see, the CSF flows easily through the shunt and into the peritoneal cavity. Here, the CSF flows into the peritoneal cavity. The shunt is based on this simple principle of physics: fluid flowing from high pressure to low pressure. The VP shunt is the only hope for people with hydrocephalus. It is changing the lives of many people, including infants, children, and the elderly. Thank you for your time, and a big thanks to S4.